Okay, in this video we're going to go over order of operations, but before I can go into order of operations I need to make sure that you're clear and understand how to read exponential expressions, because order of operations involve adding, subtracting, multiplying, and dividing, which we've practiced already with positive and negative numbers, but it also takes into play evaluating exponential expressions. So we want to make sure that we know what we're talking about when we're dealing with these. So first of all, I want to recognize that you understand the components of an exponential expression. The number that's on the baseline, the 3 here, is your base number, and it is raised to a power. That power is up here in the upper right hand corner. So the 4 is the power here, the 3 is the base. And what this means, what that power means, is the base times itself that number of times. Not times that power, but times itself that number of times. So 3 to the 4th power means 3 times 3 times 3 times 3. And so when we go to multiply that, 3 times 3 is 9, times 3 times 3 is 9, so 9 times 9 is equal to 81. So we can see that 3 to the 4th power is pretty darn large, 81, versus 3 times 4, which is only 12, or 3 times... Okay, so I just really want you to recognize that exponential expressions, they really grow fast. That operation just really grows fast, and that kind of makes sense. Adding, when you add 3, that grows a little bit, but when you multiply by 3, it grows quite a lot. But when you raise to a power of 3 or 4 or whatever, it grows even more. So it has a growth potential here. Okay, so writing 4 times 4 times 4 in exponential notation is 4 to the 3rd power. I'm not going to evaluate that one. But on this next one, I want you to see some patterns when it comes to evaluating some of these. So when we go to evaluate 10 to the 4th power, think about what that means. That is saying 10 times 10 times 10 times 10. Do you see here how I use parentheses to communicate multiplication? That's something that we want to be aware of, is that we can communicate multiplication with these parentheses, and that when we're communicating multiplication, it's different than when the parentheses are used as a grouping mechanism. So here I'm using the parentheses to communicate multiplication. So when you multiply that out, that comes out to be 10,000. Okay, 0.5 to the 3rd power is, when I write out the meaning, 0.5 times 0.5 times 0.5. Again, I'm using parentheses to communicate multiplication. And if I'd multiply that out, that would come out to be 5 times 5 is 25, times 5 would be 125, but what happens with that decimal in there? If you punch it in the calculator, you're going to come up with 125 thousandths. So I want you to see a pattern here, that in my base, I had, back here, 10 to the 4th, in my base I had 1 0, some number with a second digit of 0. In my answer, my outcome has 10 zeros. So 4 zeros. So 10 to the 4th, there's kind of a pattern there with the number of zeros. Same thing here with the decimal. When my base number has a decimal of a single place value, that means my outcome is going to have a place value equal to the exponent. If that would have been 0.15, I would have 2 place values in my base. Then my outcome would have had 0.15 to the 3rd power would have been triple that place value of 2 in there. I just want you to see a pattern, that here we only had 1 place value to the 3rd power, means our outcome is going to have 3 place values. Okay, moving on, we're going to now start applying the rules for order of operations. I think many of us have heard this term before, this phrase, please excuse my dear Aunt Sally. We may have also learned this as PEMDAS, and I think that's going to be a way that most of us recall it as well. What we mean by the please excuse, the P and the E represent parentheses and exponents, which could look kind of like that. That whatever's in these parentheses, we need to do that first. Now this is using parentheses as a grouping mechanism, and I'll explain that as we come across that in different examples. Excuse for an exponential expression, it could be some base number In this case, I have a variable, but some base number to some power or some root. So I want you to recognize here that these two are inverse operations of each other. Something to the squared power, the inverse of that is square rooting. I can come up here and kind of do another example. Something to the fifth power, the root of that, the inverse, is to take the fifth root of something. Now, we don't have a lot of opportunity to practice fifth roots, but I just want you to know that that exists, and really all I'm getting at is these are inverse of each other. That's what we mean by it's included as an exponential expression. A square rooting, a fifth rooting, a cube rooting, they're all exponential expressions because they reverse something raised to a power. That's probably could be new to some students. Okay, the my and the deer represent multiplication and division. The Aunt and the Sally represent addition and subtraction. I don't think that's real new to anybody. But what I do want to point out is that you're going to do these in sets. You need to do parentheses and exponents first. Once you've got that done, you're going to do multiplication and division. Once you've got that done, your last step is to do your running tally of adding and subtracting. So you're going to do those in that order. That's explicitly spelled out right there. I've kind of circled this in sets, so we have 3 stages in our problems. Okay, so our first couple problems, first problem, we don't have any exponential expression in here, but I do have a parenthesis in here. And I want you to see that the parenthesis here is a grouping mechanism, saying I need to do what's inside the parentheses here before I move forward. So that's 7 plus 8. Now, usually addition isn't done until last, but because that's inside a parentheses, that trumps it. It moves up. We're using parentheses as a grouping mechanism. We've got to do that first. So I'm going to go ahead and say 7 plus 8 gives me 15. I can bring everything else down. Now I'm looking at, gosh, it looks pretty similar. I've got parentheses here again. But here the parentheses are implying multiplication. So that means I need to do my multiplication next because that's the next in my lineup. I don't have any division, so I'm going to go ahead and do that multiplication, which would give me 60. I can bring everything else down. Now it's just a matter of last step. I need to go ahead and do all my addition and subtraction. So that comes out to be 73. Okay, and this next one, where to start? First thing I need to do is parentheses and exponents. I need to recognize that this square root is the reverse of an exponential expression. I need to do that first. So that's coming out as an expression. It's basically the root. I need to do that. That's my first step. So square root of 4 is 2. In other words, what number times itself is equal to 4? That would have to be 2. And I'm subtracting it, so I bring that down. I'm going to bring everything else down so I can continue on. Now I'm into my next step. Do I have any multiplication and division? I sure do, right here. So I'm going to go ahead and carry out that multiplication. And now it's just a series of I can add and subtract and work my way through. Okay, this next one, I put a little square up here just to make this a little more interesting. So we have a first step here. We're going to have to carry out this exponent. So 3 squared means 3 times 3. That would be 9. So I can bring everything else down. Now the next thing, multiplication or division. I've got that right here, so I need to do that. So that would be 18, and then 4 plus 18 gives me 22. Okay, down here, up, I've got to do parentheses. Now again, the parentheses are a grouping mechanism. Once I get inside those parentheses, I can see that I've got multiplication, and multiplication needs to be done before subtraction. This little line up here tells me the multiplication trumps everything for right inside the parenthesis. So I go ahead and multiply that, and I end up with 14 minus 6. I'm going to go ahead and carry that out. That's going to give me 8. And then I can bring this down. The 48 divided by 8 is going to give me 6. And I'm going to write my answer over here just so I save a little room for these fraction problems. Okay, over here I've got 2 parentheses, and again the parentheses in each of these cases are grouping mechanisms saying I have to do what's inside there first. So because that's in parentheses, addition comes first inside here. So I'm going to go ahead and carry that out. And when I carry out this addition in here, I should have done that first before I started writing everything down. So I've carried that out. Now I've got parentheses again, but now my parentheses are communicating multiplication. So Just kind of keep your head in the game as to what your parentheses are communicating. So now I'm going to carry out that multiplication, which would be 30 there and 30 here, and we're subtracting. If I bring everything else down, I can do my running tally, but I can see that I've got positives here of 37 and negatives here of 37. So positive 37 minus 37 is going to give me 0. Okay, so down here, this is where things seem to feel like we've got some strange things going on. But we need, before we can simplify this fraction, I have to simplify the numerator and simplify the denominator. So we need to start with each one dealing with it separately. So I'm going to cover up the denominator here so we can just focus on that numerator. So inside that parentheses here, I'm going to have to take care of that subtraction first because I have to do what's inside the parentheses first. So 7 minus 1 is 6, and I've got 24 plus 30, or sorry, 24 plus 6 is going to give me 30. I'm going to write that right over here. So I kind of worked my denominator going, or my numerator going up there. When I do my denominator, again, I've got to do what's inside the parentheses here. So now I have 3 times, and when I carry out the addition in here, I've got 10, which is going to give me 30. I'm going to draw a little line here so I can keep my work separate. So 30 over 30 reduces to 1, so that simplifies to 1. Okay, and this next one, I want you to recognize what is part of my fraction and what is not. This line, dividing numerator and denominator, starts at the 3 and ends after the parenthesis here. So in other words, the 8 and the negative 7 are whole numbers. I could collect those right out of the gate, but what I'm going to do is just really focus on that fraction first. I need to simplify what's inside that parenthesis first. So 9 minus 2 gives me 7. And so then I've got 3 times 7, which gives me 21. Okay, so that whole fraction simplifies. I found a new way to write each of those things. So basically I have 21 over 21, which we know is 1. So 8 plus 1 minus 7, that whole thing is going to reduce to 2. So the fractions just make things a little interesting, especially when it's a complex kind of fraction like that. Okay, so looking at my numerator, I'm going to have to simplify 2 times 5. I have to start with that multiplication in there. So that's going to be 2 times 5 gives me 10. 20 minus 10. 20 minus 10 gives me 10. Do you see how I'm just going to cancel out because I found new ways to simplify that numerator. So now I have 10 in my numerator. My denominator, I have 3 minus 2, which is going to be 1. I found a new way to write that. I kind of call this an exploding fraction here because I simplified my numerator going up and obviously simplified my denominator going down. Hopefully you guys can follow that. So 10 over 1 is going to simplify to 10. Okay, over here, lots of craziness going on here, and I realize I don't really have enough room in here, but I'm going to simplify my parentheses inside my brackets. I'm going to have to start with that first. So 5 minus 3 gives me 2. I'm going to be multiplying that by 2. Plus 4, and then I've got 4 plus 2 gives me 6, and then minus 3. All of that is inside brackets. I need to keep simplifying. So 2 times 2 gives me 4 plus 24 minus 3. I need to keep simplifying all of this. So when I add that, I've got 28 minus 3 gives me 25. I'm just going to write that there. And then I'm going to rewrite everything over here. So I've got, actually I can carry out this 5 times 10 5 times 2 gives me 10. So I'm writing that here. Plus 3, this all simplified in here to 25. 3 times 25, which gives me 10 plus 75, which gives me 85. Okay, here I need to do what's inside my parentheses first. So 2 times 5 gives me 10 to the 3rd power, which is going to give me 1,000. Okay, here I got to remember that 3 is the only thing that's cubed. Over here the parentheses said everything inside there cubed. Here it's just the 5 that's being cubed, so I have to start with that. So 5 times 5 times 5 is 125. So we end up with 2 times 125 would be 250. Okay, and here we've got, I'm going to have to deal with this and then this as well. So that's the starting out. So that's going to be 125 minus square root of 4 is 2. I can bring everything else down if I want. So I'm multiplying that here. I've got to carry out that multiplication. So I've got 8 plus 250 minus 2 plus 2. So that's a running tally. And if I would run that all the way through, I'd have 276. I'm looking at the clock here on my timer. I'm going to run out of time to finish this. My video is going to shut down on me. So I'm going to show you the outcome for those that last row. Hopefully you can freeze your screen and be able to follow all that. We have to simplify what's inside of our numerator here, square it. That's how we got the 10 squared. We carried out our squares here and then worked our way down. Here I needed to complete both of these exponential expressions in my numerator. That's how I got the 25 and the 3. In other words, the cube root of 27, some number times itself 3 times. That is 27. That's going to be 3. Simplify and work our way down. Okay, here I had to start with cubing. Here I needed to go ahead and carry out my division and my multiplication, but even though the PEM does, M comes before D and PEM does, the M and the D are at the same stage. We need to do multiplication and division in the order that they come in the problem. So this is kind of a tricky one because division came before the multiplication. We need to do that division first in the order that they come in the problem. So that's what I've done here to continue that problem.